Question 4, part 1. Okay, the modulus of z is between 2 and 1. So that's two circles, one radius 1, 1, 1, negative 1, negative 1. The other circle is radius 2. And since it's strictly less than, we draw the dotted lines. And if the modulus of z is in between those, it's all this region in here. We also need the argument of z between pi on 2 and pi on 4. So z can't be 0. Pi on 4 out here again, strictly less than. And pi on 2 is there. And so if I shade in that region, it's going to be this region in here is the desired region. So that's 4 part 1. 4 part 2 says in this region mark a point K to represent a complex number. So mark a point up here, I'll call it K. Now I need to mark a point M, and M will be the conjugate. So the conjugate has got the same real part but the negative of the imaginary part, so it's just a reflection about the x-axis. So this will be my point M down here. The point N has to represent negative K. Negative K is simply 180 degrees about the origin. So this would be negative K, negative Z over here, or negative point K, and I'll label this as N. Then 1 over Z, where K represents Z. 1 over Z, so 1 over Z, if Z is equal to R cos I sine theta, then 1 over Z is equal to R to the negative 1 cos I sine of negative theta by de Moivre's theorem. So hence its argument is negative theta, so it lies on this line out here towards M, and its modulus is 1 over the modulus of this number here. This number lies between 1 and 2, so if I take the reciprocal, I'm going to get a number between 0 and 1 on this line here. So I'm going to put it somewhere around there. I had to label that one as P. And finally Q representing 2Z. Well, if this is Z, 2Z is simply the double of it out here, and that will be Q out there.